Hi, welcome back. Our previous lesson was on compensating and equivalent variation. Today we'll be moving on to practice question on these two concepts. So let's start with a consumer named Peter whose preferences over good X and good Y can be represented by the following utility function, which is U as a function of X and Y being equal to x raised to the power 0.5 and y raised to the power 0.5. Let the price of good x and good y be equal to 1. Suppose M is the amount of money that Peter has to spend on good X and good Y. Given this utility function and budget constraint, the optimal demand functions can be represented as these two functions. We have looked at how to derive these demand functions extensively when we were looking at consumer choice. The demand function for good X is M, which is the income, divided by 2 multiplied by the price of good X. Now, since the price of good X is 1, this reduces to M divided by 2, and similarly for Y. We are going to use these two demand functions to answer questions on compensating and equivalent variations. The first question is, if Peter has an income of 8, find the optimal quantities of good X and Y he should consume as well as his level of utility. We know that our income is equal to 8. We know the price of good X to be equal to 1 and the price of good Y to be equal to 1. Now, since we know the demand function for good X being equal to M over 2, this is simply going to be equal to 8 over 2, which is 4. Now, if we do the same for Y, then we have Y being equal to M over 2 being equal to 4 as well. Now, his utility is going to be X raised to the power 0.5, Y raised to the power 0.5. And this is simply 4 raised to the power 0.5, 4 raised to the power 0.5, which is equal to 4. So this is Peter's level of utility at the original prices of good X being equal to 1 and good Y being equal to 1. The second question is, suppose the price of good X changes from 1 to 2. Calculate Peter's utility after the change in price. Now we have a new price of good X if we call this Px prime being equal to 2. Now the only thing that is changing here is the price of good X. So our new demand for good X, let's call this X2 is equal to M divided by 2 new price of good X. So this is M, which is still 8, 2 multiplied by the new price of good X, which is 2. So our new demand for good X is going to be 2. So after the change in price from 1 to 2, Peter's demand for good X decreased from 4 to 2. Now Peter's new utility after the change in price is therefore going to be this new X, which is 2 raised to the power 0.5, and our original Y raised to the power 0.5. Now this is going to give us 2.828. So if we call this new utility U2, after the change in price, Peter's utility decreased from 4 to 2.8. The third question is, calculate the compensating variation of the price increase. Now, typically, the increase in price will move Peter to a lower indifference curve, indicating a lower level of utility. So our original level of utility, if we call it U1, is equal to 4, and the new level of utility, if we call it U2, is equal to 2.828. So if we draw these indifference curves, we are going to find that U1 will be on a higher indifference curve as compared to U2. So this will be a typical case of an increase in the price of a good. So the concept of compensating variation is the amount of money that Peter will need to be compensated with to keep him on his original indifference curve U1 despite the change in price of good X from Px being equal to 1 to Px prime being equal to 2. All we are going to do here is to calculate this amount of money that we will need to give Peter to keep him on indifference curve with utility level 4 despite the change in price to 2. To compute the compensative variation, we need to keep Peter at his old level of utility with the new prices. To do this, we can rewrite our utility function as x raised to the power 0.5, y raised to the power 0.5. We know that the old utility is 4, so this is equal to x. Now x is m over 2px. Since things have changed with good x, we will need to indicate this with our utility function. So we are going to have the new price of good x here, and this is raised to the power 0.5. And this also m divided by 2py. Now the price of good y has not changed, so it stays the same, and this is also 0.5. What this is telling us is what level of income will we need to keep Peter on his initial level of utility 4, even though the price of good x has changed to px prime. To differentiate between our new and old level of income, we are simply going to indicate this as n prime, so that we know that m prime is the money that is needed to keep Peter on his initial level of utility despite the change in the price of good x. We know that px prime is equal to 2 and py remains at 1. So if we solve this out, what we're going to have is 4 being equal to m prime divided by 2 into bracket 2 all raised to the power 0.5, and then we have m prime divided by 2 and then 1 and all raised to the power 0.5. This simply reduces to 4 is equal to m prime 0.5 plus 0.5 divided by 4 raised to the power 0.5 times 2 raised to the power 0.5. This further reduces to m prime being equal to 4 times 2 raised to the power 0.5 times 2. So m prime now is 11.314. At the new price of good eggs being equal to 2, Peter will need an income level of 11.314 to attain the original level of utility equal to 4. The compensating variation of the change in the price of good eggs from 1 to 2 is therefore the difference between the new income and the old income. So if we calculate our compensating variation, we're going to arrive at our new income being m prime minus the old income m. This is simply 11.314 minus 8. But this is the new income and this is the old income. So our compensating variation is therefore 3.314. The amount of money that Peter needs to keep him on the same level of utility being equal to 4, despite the change in price, is 3.314. To see this on the graph, we know that Peter started from an initial level of equilibrium E1, on indifference curve U1, and on budget line B1. Now, typically, if the price of good X increases, this will move Peter to an equilibrium level E2 on budget line B2 on indifference curve U2. But we want to avoid this change in utility. So our aim here is to compensate Peter with enough income to keep him on his original utility U1 despite the change in the price of good X. So we have said in our previous lessons that this will mean that we'll have to move budget line B2 in a parallel fashion until it is tangential to the indifference curve U1. This brings us to our new budget line BC and a new equilibrium point EC. So we can see on our vertical axis that M is the initial level of income and M prime is the income that is needed to keep Peter on the same level of utility after the change in price. And what we have calculated is our compensating variation, which is the difference between these two income. And it's the vertical distance between our budget line B2 and the budget line BC. So this is all that we have on the first part of our practice question on compensating and equivalent variation. In our next lesson, we'll be moving on to part 2 of these practice questions, but focusing on equivalent variation. If you enjoyed today's lesson, consider subscribing. Thank you.